Okay, so this is our first example of solving for the intersection of a linear and a quadratic, or indeed a one linear, one quadratic simultaneous. So, as I mentioned, we're going to be rearranging the linear equation to read some variable equals bleh, and we're going to use that information to sub into the quadratic equation. Now, in terms of the notation, nothing changes. I'm still going to declare that this is equation number 1 and this is equation number 2. Though what's different is that there's a very definitive order in terms of what subbing in goes where and what sort of rearrangements we have to do. So what we'll do is we'll rearrange the first equation. Now, it's very, very easy just to get y in its own, so let's do that. If we know that 3x take away y plus 7 is equal to 0, then it clearly follows that y is 3x plus 7. We're then going to substitute that into equation number 2. Okay, what equation number 2 is then going to read is, instead of y, we know that that's 3x plus 7. So we'll write 3x plus 7 is equal to x squared plus 3. So rearranging, we get x squared. The 3x is going to come over, and 3 take away 7 is negative 4. And that's equal to 0. In this case, we're going to get two real solutions. We just need to determine what they are. This does factorize into minus 4 and plus 1. Because we get the minus 4 contribution, and then minus 4x plus another x gives us minus 3x. So we have two possible solutions using the root factor theorem, that either x is 4 or x is negative 1. Then from there we just need to find out what the corresponding y coordinate is. Again, you want to pick the easiest equation for this, and I would personally find equation 1, or at least the modified version of it, easier to sub in. So the way that I tend to write this is I'll just say but y, the corresponding y coordinate is 3 times x plus 7. So if I maybe label these as x1 and x2, then I can say that y1 is 3x1 plus 7 and y2 is 3x2 plus 7. So that's 3 times 4 plus 7 in the first case, and 3 times minus 1 plus 7 in the other case. So we get the y coordinate as 3 fours are 12 and 7 is 19. And y2 is 7 minus 3, which is 4. So the solution, or rather solutions, are as follows. Note that we have to be pairwise specific about what we pick for our solutions, which is why I write the x1 and x2 notation, because the x1 and the y were not going to go together. So one possible solution is 419, and another possible solution is negative 1, 4. Of course, you can use, say, Desmos or GeoGebra to graph that and easily convince yourself that those are the two intersection points.